Yeah, I'm good. I'm good. Yeah, that sucks. Okay. So yeah, yeah, it's fully good on my side. So yeah, I can kind of recap here. So what we missed. So I was going over this DeFore and Pruner experiment. Did you hear any of that part? Okay, yeah. So these guys they took the original SAGNet configuration and they reproduced SAGNet's work. And I think that's an important distinction too, the way that they did their experiment, because in modern renditions of Michelson-Morley experiments, so called, they don't use a device analogous to how Michelson had it set up, and they don't follow they don't follow the work the way that Miller did it. To try and reproduce these things. But the way that they change the apparatus completely affects everything. So the first step that they did, I think, really showcases the integrity that these guys had for their experimentation, because they reproduced the SAGNEC in its original configuration. The only modification that they made, they actually were able to use some of the same parts, but the only modification that they made is that the diameter of the disk is 2 times bigger than SAGNEC's original configuration. That's the only thing that they changed. They just made the disk bigger. Yeah, so it's like really cool that they were like, okay, well, Sagnac said he did this, but like, let's see if we can reproduce it, because that was in 1913 with Sagnac. So this is 1942. So they were like, let's see what's going on here with this rotating disk situation, and they reproduced a fringe that corresponds to the rotation of the device at 1 turn per second, which is a very important distinction, right? So all these measurements that they take are going to have a first order dependency on the rotation of the platform, and the platform rotates at 1 turn per second. So with the first Sagnac experiment they did, all the instruments are located on the rotating device, and then they got their fringe pattern that corresponded to the prediction as laid out by Sagnac, right? Which produced a fringe of what was it? It was like, it shows in the pictures here as I scroll down. We'll get to it, but anyway, they did another configuration here where they have the light source fixed to the lab wall, and they use two collimators to keep the beam in focus as it transfers from the stationary to the rotating platform. And then it completes its circuit within the rotating device, and it ends up here in P, which is the photographic recorder. And that's where it's going to get its take the fringe displacements. And the what determines what a reference frame is, like, is it an inertial, non-inertial, etc. All that is determined by the observer. So the observer here is located on the what's relativists call this a non-inertial reference frame, but Einstein defines a uniformly rotating platform as an inertial frame. And states that any situation where his linear equations hold true, so should it for a rotational, as long as it's a uniform rotation, it's not deviating, accelerating, that kind of stuff, right? So some relativists will argue that because it's rotating, it's a non-inertial frame, blah blah blah, but it's not true. Using relativistic math, they can take the reference frame of the center of the rotating disk and extrapolate outward from there. But what they can't do, what they found, is that they can't do it from another location on the disk, and we'll get into that configuration, or that experimental configuration, towards the end here. But yeah, so the important thing to note here is that for like 8 years, the Sagnac effect went unanswered by special relativity and general relativity, and it wasn't until Paul Lavue stepped in with general relativity to basically say that the energy of the rotation of the device creates little pockets of length contraction and time dilation. And that's just, of course, expressed through abstract mathematics. It has no physical substance to it as an actual meaningful mechanism for anything. It's just an abstract kinematic description. So that's all they offer for that, and they can only do it from a specific reference point. And in special relativity, the first two postulates are adherence to Lorentz symmetry, meaning that all inertial frames are equally valid, and that's expressed through the mathematics. So any point on any not just using the center here, relativity says that it should be able to derive the correct displacement from any location on here, because all inertial frames are equally valid. So if they were going to do that through the mathematics, that's how they would what's it called? Test that hypothesis, rather, right? Mathematically, Um, and then the second postulate being that the speed of light is independent of the motion of the source or observer, right? Um, so keeping all that in mind, and how Einstein describes or defines an inertial frame, and how he defines a rotating frame when it's in a uniform motion. It should be absolutely equivalent to someone who's stationary. Okay. So, any questions so far? Yeah. So for this diagram, this is the second configuration of their setup where they have the light source here. This is your S. It's shooting a beam into this collimator here right before it doesn't. This collimator isn't attached to the platform. It's just refocusing the beam into another collimator that's on the rotating platform. And when those focused beams get aligned, it hits this split mirror, hits this, and then it completes its rotational path back to here, and then it hits your boy the photographic recorder that's on the rotating device. So it's like the device is rotating, and it has like a split second, so to speak, but it's light, so it's really fast. It has enough time to complete a circuit like 17 times or something in the time it takes for that one pass for them to line up, right? So more than enough time to get the reading. But that's kind of what they got going on. Does that kind of make sense now? Yes. Yeah, well, the observer with the observer's location determines the what the is it if it's an inertial reference frame or not. So like the source being here doesn't determine anything about the reference frame itself because this isn't even attached to the rotating device. So the distinction there is that the observer uh is what determines the reference frame if it's inertial or not. What's happening to the observer. Yes. Yeah. So yeah. The recorder would be substituted as observer. Yep. Yep. And then a couple other distinction here too. So a reference frame implies an observer, like an actual physical thing that you would be able to make like dynamic predictions with, right? And then a coordinate system would be like an abstract kinematic situation. And the way that the lingo is facilitated in relativity and mainstream physics and all that, the distinction is super blurred. I was reading this interesting paper about that subject from Robert Bennett, who goes into detail because you know how we say like from our outside perspective, we make the broad claim that physics and stuff is compartmentalized, right? And they laugh at us. They're like, "Haha, you're fucking stupid. You think we're compartmentalized?" Well, yeah, like this is the compartmentalization right here. The blurring of the lines between a frame that implies an observer that has like practicality that must be true, and a hypothetical coordinate system that's useful for analytical purposes and things like that. So really interesting distinction there. And then so what relativity or what were irregardless of however Einstein phrased it in the beginning, how they've what's been put forward now is that these kinematic frames, these analysis frames, these hypothetical frames are all valid in real frames, right? So, so that's kind of what they've done there. So when they say um that the SAGNEC device that how Einstein defined it as being able to fully incorporate any of the effects as long as it's an inertial frame, as long as the stationary calculations hold true, or for an inertial frame or observer, sorry, um, that it should be good to go. But what we're going to find out is that when you force them to not use a preferred frame, right, this center location stationary non-rotating, relativity fails miserably through further experimentation. So yeah. And then so these are the fringe patterns. This is from the stationary, or I'm sorry, this is from the original configuration here. This is showing the fringe displacement. And then this is from the second configuration where the light source is fixed to the lab. So this is showing that um, that the inertial motion of the system is responsible for the fringe pattern, and it doesn't matter if the light source is moving or not. It's all determined on the observer so far. This is what they've experimentally deduced from this so far, is that the the that the inertiality, right, the velocity of the system or whatever, is 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 what is what is showing the effect, not it doesn't matter if the source is rotating as well. Sorry about that. There's some background noise at my house. Okay, so for their third configuration, what they did is they have a light source fixed to the lab. They got their collimator here. They have a disk above that's stationary. They have a mirror here that splits off, beam splitter, and recombines. But when it splits off here, it hits a 45-degree angled mirror, hits another 45er, and then down here is your rotating uh, frame, right? And then in the final configuration of this, they actually attach an observer here to take a recording based off of this recombining and splitting mirror here, and then they still have they have one here that's on the rotating device, and then they also have one that's on the lab wall, because this, like, how it reflects back and recombines. They have a dual setup. So so what we're going to see here is they're going to try and isolate the effect of the inertial system, its motion, and see how this affects for an Einstein defined inertial observer that's actually stationary, and versus an observer that's inertial and rotating with the system, uniform rotation, stationary observer, all that shit, right? So basically these two frames should be equivalent, right? Right. So we're going to see what happens. Right now. I In relativity theory, the fixed lab observer should see no fringe, right? The spinning situation down here, recombining up here, because it should not be. They should observe no fringe. And then the stationary, I mean, and then the recorder attached to the device should see a fringe. It should still see it because it's with its inertial, it's moving, right? But because they're not actually connected physically, the stationary lab should see no fringe, right? So here's the overall topographical view of what it looks like, and I kind of color coded the mirrors and stuff like that, or whatever, so you can kind of see what's going on. No, you're good. Yeah, yeah, they're gonna compare. Yeah, they're gonna compare two readings. Yep, yep, they're taking two separate readings and comparing. Yep. And then, so one more time, topographical view of it. Your C here is your axis of rotation between the two disk, and then this top part here is your stationary disk that reflects back to the lab wall, where the observer and source are stationary. And then this green section here is your rotating, all that, and this should be green as well right here. Um, but yeah, so this is where where the observer attached to the rotating platform was. Yeah, so this is where yours located, right? So what they did here, so here's a picture of what it looks like. It's not very good, but the distance here between those two platforms is only 4 inches. So we have the rotating platform is on the bottom, and we have the stationary platform on the top, and then fixed to the lab behind it as the source and an observer. And then there's a recorder here somewhere. Oh, I think this might be it right here. That's on the edge here of the rim, where they take their other measurement on the rotating device. All right. So what they found here, this is a topographical view of the path of light that it will take. All right, between the two disks, and this is the fringe shift patterns that they got. So for the lab guy, or for the observer fixed to the lab, they got a fringe that fully matches the rotation of one rotation per second. And for the guy on the device, they got the same reading. Or yeah, for the guy, fixed to the rotating frame. First order dependence on rotation, right? So that's pretty crazy, right? So this rotating system that's not attached. Second. This rotating system at the bottom here that's not attached to the wall is changing the speed of light for the observer, right? So how Sagnac thought of uh, the ether wind, right? His the way that he geometrically described it was that there was a uniform atmosphere, right, of ether wind, right? Because he was a globe lad, right? So he imagined that we were surrounded with an atmosphere that rotates with the globe of ether, right? And within that ether field, if you're rotating on the surface of the Earth, you generate your own ether wind within that greater vortex, right? So the way that he describes the analogy here, I'll read it off. In a moving system as the whole relative to the ether, the propagation time between any 2 points in the system should change in a way similar to a stationary system subjected to an ether wind. The relative speed at which point of the system will be the same as directly opposite to the same or to the speed of any point and would contain light waves in a manner similar to atmospheric wind carrying sound waves. So it's getting that propagation speed boost, and it's catching a delay, right? So going upstream and downstream kind of way because it's all flowing in one direction, right? East to west. The greater ether vortex, right? So the observational of optical effects of such an ether wind relative to a stationary ether will constitute a proof of the ether's existence. So what he's talking about is that counter propagating uh, ether wind from a rotating, within the atmosphere, the greater atmosphere, right? So just as an observer, just as the observations of the wind relative to the atmosphere on the speed of sound on a moving system would constitute everything else being equal as proof of existence of a stationary atmosphere enveloping the moving system, right? So absolute body bag because Sagnac read the full electrodynamics on moving bodies paper. He knew that how Einstein defined an inertial system, and or I'm sorry, an inertial frame, and that's why he made that claim, right? Because the Sedgwick effect fully applies to it. And let me look at the logic with what he showed and what he measured. So what he measured is that the speed of light when it's recorded has a first order dependence on the rotation of the device. So it varies, fluctuating based on how much it is, how much rotation there is. It's proportional to that directly to the first order. It's insane. And the only thing that would facilitate such a mechanism would be the ether, because in regards to how they used to say like what's an absolute reference frame and what's it relative to, and there's no absolute motion because there would have to be the implication would be that it's with respect to an absolute frame that you would compare it to. All these things that relativity denies uh, is the mechanism that facilitates that variance to the first order degree. So yeah, absolutely. Absolutely. 1 second. So it is Ford printer 1942. Yeah, this is great. And then my boy Robert Bennett, who's going to be joining Witsit on In the Field soon, hopefully, is going to do a two-part presentation on all of this, like philosophy and science, and like the basis of, or like why it's important to have both for to have a framework of interpretation before you even get to the crazy shit like relativity and all that. And then on the second part of it, he's going to break down all these experiments, Wang, Aries failure, Michelson Morley, Michelson Gale Pearson, like all these that are on this list, Dayton Miller, Yuri Galev, Monera, dude, he's going through the whole gambit. It's going to be awesome. So definitely check that out when it comes to fruition. But yeah, so this guy's paper right here, he points out a lot of this and shows and stresses the importance of the kinematic and dynamic relationship in mathematics and how one is used to, analyze motion and not necessarily describe the mechanics behind it. Or like provide an underlying mechanism, right? Because take a look at the framework for special relativity. There's no mechanism. They literally can track the coordinate system to to their measuring stick to the speed of light. So like it's crazy. Um, yeah. All right. And then, oh yeah, Robert Bennett right here. So the foreign pruner. So there's their analysis, and then I'll drop the papers here in 1 second. It's nuts. It's nuts, dude. The the only frame that we can do things in, the only frame that's in dynamics that's actually covariant is the lab frame. So the stationary non-rotating frame is the only frame that we test things in, or that we can test things in, and it's only explicitly showed that there's a variance in the speed of light proportional to the rotation of the system, and it's like, oh, I wonder, and then so. So we've only ever seen a variance in the speed of light, and we're like, oh, you know what that means? That the speed of light's the same. And reality is changing in the direction of motion to make it seem like the speed of light's changing. Yeah, dog. Like, and then David Blaine like comes down from the, stadium or whatever. And he's like, I did it. Or,
Right.
like it's like, what are you talking about? Yeah, so 1942, let me get the deformed Pruni.
It's such a convenient conflation.
Yeah, and it's like, and kinematics has a place in like the abstract mathematics and stuff like that. Like you can analyze motion of a system, make predictions off of it, and then apply dynamics to it, and then see if the predictions hold true, and then you start forming laws of motion, right? So like all the like they call it they what they used for dynamics and analysis, the mathematics that they use a what do they call it, a Lagrangian something. But anyway, it just like analyzes it. It's like real, like it's calculating the real forces and all that kind of stuff to make the predictions and see if your predictions hold true based on your kinematic stuff. And then from there, you recompare, and then you're either experimentally verified or falsified, right? But like they just never apply that dynamic situation to relativity, because everything in the sky is abstract, right? Like as long as they convince enough people that the stuff in the sky, holds true for relativity, the effects that they measure down here, with the variance, they're like, oh yeah, of course it changes, gravitational field, potential, and all that stuff. It's like, that's why you see these experiments like Heffel and Keating, Pound Repka, Pound Snyder, and all these things that are like supposed to be supplementary to the gravitational field effects that support relativity theory. That's why when you read the papers of them and you like in it, they don't prove anything about the so-called relativistic effects, these kinematic effects that are used in the abstract mathematics of relativity theory to describe motion, right?
Right.
They're
Is
hollow,
it
and that's why.
Lagrange points? I just put a Google search on that because I know that it's like
Yeah,
parking spots in space.
so Lagrange was a mathematician slash physicist, but according to sources, he was more of a mathematician. Um, but yeah, he came up with a way to analyze the motion of a system. I forget what it's called. I have to pull up Bennett's stuff on it. Let me see if I have the notes available real quick. That'd be pretty clutch if I did. Oh, I do. Okay, cool. So pull this up. See that? Okay, so kinematics, a branch of applied math dealing solely with descriptions and measurements of motion. Possible. This is from Robert Bennett's paper that he wrote. I don't have or it's in here somewhere. I just don't remember what it's titled, but I'll look it up. Oh, relativity paper analysis and obituary. There we go. Shout out to Robert Bennett. So kinematics, a branch of applied math dealing solely with the description and measurements of motion, possible real world motions, and abstracted with kinematic variables. So there he goes over the variables here. In abstract modeling of space, the motion of an atomic electron or galactic star would be, a point would be the same point motion in a circle. All physical properties like mass, etc., and all that are ignored, right? So they come up with their own things to describe the motion that's happening in the system, and then based on that, they try and make predictions and stuff like that. And then we're going to get into the distinction of dynamics. So dynamics, a branch of physics dealing with the predictions of future motion based on Euler and Lagrange equations, the laws of physics, as derived from the Lagrangian variational principle of calculus. Specific real applications and predictions of motion include additional dynamic parameters like mass, momentum, moment of inertia, force, torque, and all that. So all the important factors when you're actually trying to model something. So like, Witsit pointed this out one time, and I thought it was really interesting. I didn't understand like what the distinction would be, because it's clearly an odd contradiction, right? So for the mathematics that they use for orbital mechanics and stuff like that, when they're like launching to the moon and whatnot, they use a geocentric coordinate system and all that, and they change the way that the forces that they use, and it's like, why are you using all these crazy, like that doesn't make any sense. Why do you switch? Well, when you're doing like a real world application and not pretending, you switch to dynamics, and the framework of what how you're calculating changes based on all that. So your starting reference point is going to be stationary, non-rotating. So that's why they use the geocentric coordinate system and all that to plot out how they think going through the gravitational field is going to affect their momentum and direction and motion and all that, right? Like how they're plotting out all that has to be done through dynamics. So that lab frame has to be covariant with all other frames, right? Because everything stems from that. Like you could play around and say like from a reference frame of the sun, blah 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 blah. But like on the for real, we're taking it back to where we can go, which is the stationary non-rotating frame, right? So when lives are on the line, when money matters, when equipment is could be lost or damaged, like you're going with dynamics. So kinematics, the measurement and interpretation of motion by abstract mathematical models used to describe a point motion by kinematic variables. So there's the variables again. So time, initial velocity, final velocity, acceleration, displacement. Kinematic laws include acceleration, path of curve r, speed, all this kind of stuff, different types of relative motion. So, the theory of relativity, is it a big surprise that it's able to make some accurate predictions? Well, when you have the leadway of a coordinate system that conforms to whatever you need it to, well, heck yeah, you can make some cool predictions, but are they dynamically equivalent? Are they meaningful? Are they physically meaningful? That's the $1 million question. So dynamics, the prediction of motion using the Lagrangian method and function of functional variation. So going through all this mathematic stuff that I don't fully understand, they analyze the system and apply like real actual variables to make the predictions of motion, right? All right.
So no, wait, no, the Lagrange points are like parking spaces, and from what I've heard over the years in the debate about this whole idea is that they're convenient for the explanations mathematically more than anything.
Yeah,
right. But then this guy's kind of attributed to being talking about the dynamics, but to make the dynamics work, maybe the Lagrange points were necessary for the mathematics to also work somehow or something, right?
Yeah, that's probably why they gave him the, attributed the name and kept it going or whatever. But yeah, it was yeah. So here is
I just profit for the question from a new perspective. Hi, Alan. And I have seen your debate with Mike Tom. It was a beautiful debate. So wanted just to say that I stayed not long. I need to go.
Oh, you saw him kick ass last night, huh?
Yeah. So go on. I finished my point. I wanted just to say hi on GG.
Oh yeah, dude. Thank you, GG, bro. Yeah, it was a GG, huh? Yeah, that's what's up, man. That was fun.
And he just fucking crushed him over at Geo's, by the way, too. He was making baller tears.
Oh, did you? I'll have to watch it later. That's awesome, my man. I got a backlog of stuff to watch from you, Dave.
Yeah. I'll end up recording the part where he came in today. It was pretty good. Yeah.
Epic. That's what's up.
They didn't want to hear it. You got JA saying, "Oh, well, he's just like any of you other religious zealots, just claiming things, When he's got like the space agency, it is, like talking about like details and stuff. They were just like nobody piped up, and Zanuck and Kosho left, and then we started talking about planes, and then Zanuck came back, and he still got embarrassed. But go ahead. Sorry about that to interrupt you. But yeah, the dynamics and the kinematics. Shout out to Michael Brenner, by the way. Yeah.
Yeah. Shout outs to Michael Brenner. I'm definitely going to have you read some Michael Brenner at the end, so be prepared.
Okay, cool. I'll
because he's got some excellent an excellent take on it. It's really, really good. Here we go. So here is the way the two concepts support the scientific method. Kinematic data analysis of a system establishes a reason for forming a hypothesis. Theoretical predictions are made via the dynamic Euler-Lagrange equations. New kinematic test data either supports or refutes the dynamic theory. Realization that only certain observers or reference frames could validly predict motion was probably first documented by Newton in 1687 in the Principia, where the prediction of the spinning bucket observer failed to predict reality, the radial force on the water, but the laws of physics at the time were only Newton's three laws of motion. Later development of calculus and the variations by Euler and Lagrange in 1755 gave an algorithmic prescription that determines the laws of motion by variation of energy function integrals. Very cool. I don't have Twitter, Sacred. Let's see. Okay, yeah. So the role of the reference frame choice has not been the main focus of formal mechanical study. Oh no, hey, you don't say. When basic definitions are not precise or distinct between kinematics and dynamics is ignored or suppressed, then the meaning of an inertial frame to physicists is confused as it was in the building of the Tower of Babel. So yeah, kind of what I was touching on earlier about the important distinction of a reference frame and a coordinate system. Like they're not interchangeable. They have different implications. And not being specific about these things is what has led to all reference frames are equally valid. Well, which ones? Like dynamic ones or hypothetical kinematic ones where a guy's on the sun and we're looking at a experiment on the earth and we're not seeing contraction. Like what what are we talking about here? Well, no. What I think ties it all together is the belief in space. Because without this, you're not moving. You're not. It's like there's no scientific evidence. There's nothing, right? So unless you believe in all this stuff, you can't have star. You can't be on Tatooine. Can't get on a Tie Fighter. Like all that stuff is just you know you like you a lot comes with not accepting this stuff. You know, because like we're at like the end result of it, right? Like this is where it leads. So like somebody who isn't willing to take it as far might take it so far as to be like, well, the theories that describe everything, aren't accurate, but like space is still real, you know. But we see what they've done, and they've constructed the entire thing's a fantasy. It's a giant mathematical play. And all right, so that's all I gotta think for. Oh, let me I think I'll close out on the pruner. So did I cover their last experiment? They got with the road with the two observers matched. They both got uh, a friendship pattern corresponding to the rotation of the device of the part that was rotating, even though there was no reason that that there should be a variance and see if special relativity or if relativity theory at all were true, right? So there's a couple possible interpretations that they go over here. Um, and then what they do at the end is they test the first postulate of special relativity. Are all inertial frames equally valid? So what they do here is they calculate how much fringe should be displaced if the observer was in the traditional location of the SegNet configuration, instead of on the lab wall or on the night or on the rotating device. And what's it called? The classical theory predicts 0.053 in the fringe distance, and in relativity theory predicts 0.005 in the fringes. They're 10 times off. It's not like GG, right? Yeah, not even close. So the whole claim about like, oh, they're all valid, we can do it from anything, is equations hold true? Nope, sorry, you just got played, player. Now, Paul Lavue comes in and he's like, hey guys, it's important to remember the importance of choosing the correct coordinate system when describing a system that is in rotation. That's cool, man. That's a valid point, Paul. Let's hear him out. So he says if a device is in rotation, the gravitational effects should pull it towards the center. Thus, the optimal choice to do the calculations should be from the center. Cool story, Paul. That's great. That explains your initial reasoning for choosing that location to calculate from. But can you do it from another location, as you say? No, you can't. And that's the only thing he had to say about this. And he knew about the experimental results. That was his only rebuttal, was to reify the initial claim that to try and say that the only place that would be valid on a rotating device would be the center. But that's just like your opinion, man, to quote the Big Lebowski. All right. So that's the foreign pruner absolutely destroying special relativity in 1942 using Aether effects and validating Sagnak's initial hypothesis about the geometry of the ether wind. It is a uniform rotation, and within that, your movement generates its own ether vortex, and that is going to change how you see or how you receive light. That's what they proved. Special relativity says that what's that? Ah, dude, no, no, dude, we have to correct them and fucking contract them. Yeah, man.
Hey, since Model Builder and I and maybe a couple of our missed the first part of your presentation, I'm not asking for you to go over the whole thing, but maybe summarize or have someone else summarize for a conversation about it.
No, don't. It is saved on YouTube.
Yeah.
Oh yeah, I can just go back and listen to it. But I thought for conversation's sake,
I stay like 20 minutes or so on the. I will do my little game, so I will listen to the full things.
Yeah, so will I.
So
I just thought for conversation's sake, since we want to talk about some of the stuff he said, I'd have a hard time contributing without hearing the first part is all.
Oh no, I got you. It's not that much. Because you guys already know like most of the stuff. Yeah, I got you. So yeah,
exactly.
So these guys reproduced the Sagnac effect of 1913 in its traditional configuration, where all the instruments are placed on the device. They did a secondary configuration where the source of light was fixed to the lab wall, so stationary, to see if if what was causing the effect, if the source of light had any relevance to the effect, right? So they proved that. I'm sorry. In this experiment, they showed that all that mattered was the rotation of the device, because the fringe shift corresponded to the rotation of the device at 1 turn per second to the first order. And then here's a picture of the comparison of the fringe patterns. So here's the traditional Sagnac setup with the fringe patterns, very cool. And then here's the stationary light source showing the same fringe patterns. And then they did a third configuration where they had a light source and recorders fixed to the wall, and one recorder fixed to the rotating frame. And they had a stationary frame here that is connected by 45-degree angled mirrors on both sides. And the light beam hits this, hits the 45s.
Hey, real quick, are you trying to share a screen? Because I don't see a screen. That you're not sharing screen anymore for some reason. For me,
webcam.
No, it's only you. I think I have the screen. Can you scroll to see if it's updated? Yeah, it works.
Oh, okay. Maybe I have to. It doesn't matter. I'm sorry. I just can't see it for some reason. Maybe it's my internet or something. But
just reconnect.
Is it okay? Yeah. Sorry. By the way, I just posted. Since Model Builder has to leave soon, he did his own laser test on his table, and he was talking about putting his finger on the table and having it throw it off because it's so sensitive. But yeah. But anyway, I'll be right back.
Yeah, it's totally explained in this experiment. This experiment blow my mind every time. It's like beautiful idea he has to change the frame of reference. So,
the foreign Pune?
No, the frame of reference. You change the frame of reference of the light by putting the light outside of the experiment. I get it right?
Yeah. That's the foreign pruner that did this. That's what we're talking about. All right, Dave. I took some screenshots so you can kind of see the configuration of the apparatus, since you can't see the video or whatever.
No, I can see it now. No, I'm there. Cool. I'm there. Yeah, I just had to rejoin.
Oh, gotcha. Okay. Yeah. So that's it. So
this is a totally new thing that you just discovered. That's just what did you say? Foreign pruner?
Yep, the foreign pruner from 1942.
Foreign pruner.
Yeah, I didn't discover it. It's been like where did I hear about it at? I can't even remember. Oh, I think it was from James Demio's site where he has the whole list of Aether experiments, and I just started looking over it, and then that's how I found Robert Bennett, who has a review of it. So this paper, in conjunction with the deformed pruner, really helped me understand it, because I must have read the deformed pruner paper like 17 times before it started making sense. And then I was reading Robert's paper here, and I was like, where is he getting all this from? Like, what does this mean? And then, and I just had to keep going back and to get it. But yeah, the breakdown is awesome here. Like all the stuff that I was talking about, the kinematic relationship, the how each experiment specifically invalidates relativity theory, all that stuff that is broken down in here from him. Really cool stuff. Highly recommend reading that. And for those who don't know who Robert Bennett is, he is a PhD physicist. He taught physics for like 30 years, at a high level. Like his thesis that he got his PhD on was on gravitational effects of rigid bodies. Like, this was a relativity guy, through and through. And then, he just realized, that was all BS, had that waking up moment and started. What's that?
And he's going to be on with Witsit, you said, right? Coming up.
Yeah. We have it planned to do it in the field episode where he's going to do a 2-part presentation.
Sweet. Now he hasn't come out publicly at all before. Like that's going to be his coming out to the public type.
Oh no!
Type,
No. He's not a flat earther or anything. He's a geocentrist. But
okay.
he co-wrote the book with Robert Sungenis.
Oh, okay. That guy.
Yeah,
okay.
Yeah. He's contributed a ton of work to geocentrism. Like a lot of his papers that he's posted since his retirement are just absolutely annihilating the motion of Earth. Like,
could you just for me explain geocentrist? Is he believe on a globe, but a stationary globe?
I think so. Yeah. Yeah.
However, that's possible.
Yeah, because I have a hard time with map and so on. Because I know for a fact we're stationary. The observation tend to a flat Earth, but if we are not on the globe, that imply there is a huge hiding things in the cartography. You understand what I mean?
No, absolutely. Absolutely. And I don't think that he's ever even like familiarized himself with that stuff, because he's an older gentleman too, and he's retired, so I don't think he's like necessarily even like looking into flat Earth and all that stuff.
It's so funny. Isn't it weird the degrees that people allow themselves to go to without thinking that like it's also level? Like I've been trying for years now. I've been trying to think of the perfect question to ask a geocentrist or a concave earther that just shows them that there's no upside down people. Okay, can we just get over this idea, please?
Yeah. Well, again, what I think ties it together, though, and I'm not speaking this to Robert's perspective. This is just what I'm conceptualizing in my head. Is that I think that the reason that they keep the globe and all that is like to kind of still have the idea. They're like, oh well, yeah, there's satellites and people went to the moon, and like, yeah, there's space travel, but it's just going to be closer, maybe. You know what I mean? Like it's like because think about what it would mean to not only say Einstein's wrong, but to then turn around and say that like NASA's not going anywhere. You know what I mean? Like you gotta like that's a whole nother level of commitment to.
Especially if you have a name for yourself, protect,
right?
Like
right.
And you don't want to be dishonest intellectually with yourself, so you have to convince yourself that you can go so far. But then there's they almost know that they're going to be losing credit with the mainstream or whoever, the people that might approve or disapprove of what they're saying, so they don't allow themselves to think it because they know how they're going to be judged if they do.
Yep. No, that's absolutely it, man. And then I got some anecdotal info to drop too. So Bennett actually reached out to Ruyong Wang of the 2004 experiment where he linearized the Sagnac effect, and asked him if he was interested in like pursuing more tests that would falsify relativity theory. And Wang declined the offer. And the way that Wang was speaking to Bennett, he was saying that he was like, yeah, it was clear that he was intimidated and like he didn't want to pursue it because he would like lose his career. So
Yep.
crazy
Makes
because
sense.
a lot of I've read a bunch of Wang's papers and like there's like at least 3 or 4 of them are like, hey, there's a huge discrepancy here with relativity theory. Does anyone want to do these tests and like pursue this? And I guess they got a talking to, because he never pursued them. And then when asked if he was interested in pursuing them, he declined.
Well, that makes, at least he's acknowledging that he knows he'll lose his career if he even says it. But the other guys may be unconsciously not even allowing themselves to think it. Like we were just talking about. Like that's maybe at least you have to give him credit there for knowing that this is a career-ending type thing.
Yeah, absolutely.
Huge. I can't
What
wait
up,
for that.
JT?
What's it say?
Yeah.
When, do you have any kind of time frame? Is it going to be coming up soon, or you don't know?
No, I sent Witsit a message the other day. I'm just waiting to hear back from him to get it scheduled. Bennett's got the presentation already set up. I looked through the slides. He had 68 when I last looked at him. We're gonna break it into at slide 30. We're gonna stop, take a break, and then do the second half at a later date. But yeah, the heliocentrism will never be the same after this. Like I'll say that because this dude, he's so precise with his language and like the definitions. Like you can't like all this like dynamics and kinematics and what it's a reference frame and a coordinate system. Like when you start actually defining this stuff and you like when you hear it out, it's gonna be insane. Like it's never gonna be the same again for the relativist dude. It's gonna up our game to an insane
How are,
degree.
Now, when you
how are we going to spin him up to have a little chat with McToon to start debating for us?
Oh, he's
not going to debate for us because he's a geocentrist. He's not a flat earther. But it'd be interesting to look at his slides, or maybe even ask if you have yet, to figure out how they convince themselves that there's still people upside down, or that the planets are going below us and the stars are going below us.
I just told you, like I'm sure he's like has extrapolated some gravitational effects and that cause something, right? So I'm sure that that's the like because that's the easy way out, right? Like you don't have to, it just makes sense. It's the path of least resistance, in my opinion. That's what I would do, right?
Well, Witsit talked about this when he was going to have Robertson Jenis on, and how he was going to, like maybe subtly mention it, or maybe at some point even talk to him on that level. And but it'd just be interesting to figure out exactly how it is. I mean, it is the path of least resistance as far as what we've been given for the model, but then maybe like that. Of course, the next step is then to show them at some point, or yourself at some point, how it is that they're able to take this, and the gravitational effect is not necessary for it to work in the way that they think, or whatever. So somehow,
did you hear Witsit's talk with Robertson Jenis already that he had in the field?
Oh, it's great.
Dude, it was awesome.
And then at the very end, he's like, okay, next time let's go like debate format, or let's go a little harder, because it was real gentle and they were just talking about what they agree on. And he was just really respectful of him and thankful that he did the principle. And I can't wait for him to have a little deeper talk.
It was so crazy how much Robertson Jenis knew about like the reverse engineering and all of the discrepancies and the oversights, intentional oversights. And, like he's like fully there, but he doesn't get the next thing, which is like, no, it's not even a ball, bro. It's not even a ball.
Yeah, it's like, it's that component that a lot of people don't want to talk about, the spiritual component about being blind or having a veil over your eyes. It's truly a blessing if you can see clearly the truth, or at least get closer to the truth than some. Because the biggest thing that I've thought about lately is, if a person truly thinks that they already have the truth, they view us as we're deceived, we're goofy, we're dumb, we're silly, we're retarded or whatever. But it's a humble thing to set everything aside and investigate what's presented, both globe and flat, And then you can actually start finding the truth when you come into it with kind of a clean slate.
Yeah. Yeah, and it's crazy how it can be so well thought about just as a geocentric model. Like obviously it works, and that's the thing. If we're talking about the dynamics now and how he's showing that the dynamics work with the geocentrism, and that's what bugs me is that like the dynamics have to work over a flat Earth too. And what is it about the dynamics that would have to change if that were the case, as far as what they're, the results they're getting? That's what I would be interested in figuring out.
I don't think.
But they've looked at all the other holes. Like that's the thing. Like the interview with Robert St. John, he's like he sees all the holes. Like he gets how they
It happened
totally
to me.
finagle things.
There are certain things that they aren't willing to acknowledge, right? So,
Yeah.
like Sangenis has debated flat earthers before, like he's aware of it, like he's not ignorant to it, right? So he's obviously seen he's seen like things like the black swan and like a lot of all that, like all that like basic kind of stuff, right? That we've all seen. And then when what's his name, when Pitch Lumen was asking him about that in a debate, he acted like he had never heard of it and that kind of stuff. And it's like I've seen that done with some other with another academic guy that I know, where I've shown him some observations that defeat 8 inches per mile square, and the guy's just just no acknowledgement of it, and then like weeks later he'll be on stream and I'll catch him talking for a minute and he'll be like, yeah, I just don't know what's up with these crazy science deniers. And it's like, dude, dude, but people are just gonna do what they do. Like when they hit that threshold limit, like it's GG,
Yeah.
like we probably all have threshold limits on stuff too,
Yeah.
I
Well, I guess so. Yeah, that's true. We all have our limits of what we'd rather not know. Almost.
I think just the social ramifications of it is just like, oh man, I'm going to be one of them.
Yep. Yeah, man. Nobody wants to be the guy. The Ash conformity experiment proves that in situations where the stakes are nil, right? Where you're just where the stakes are some people you don't know might think you're dumb, like that, like yeah. Yeah, dude, like when kicking, dude, if you don't go kicking and screaming, there's something like not right, Because I went through the same thing. I'm like, come on, man, are you for real? No space. I'm like, the moon landing, they didn't go. They just pretended. It's not even not one moon rock. Like, yeah, like, well, that was like my early journey.
Yeah. No friends and family.
Yeah.
I don't want friends and family.
Yeah.
And Whitsett said it like it's you're gonna if we go to geocentrism first, he thinks that's a ticket for the ballers, because they'll go geocentric at least to start with. But it's just like ultra frustrating. So yeah, it's frustrating because there was a troll back in the day that was like the major I don't know, troll of the flat Earth at the time. There was like 1 or 3 or 4 of them, but it was what's his name, Tim Osman, and he was like, in the debate with him, even when I was talking to him, he's like, I'm okay with it being stationary, but it's definitely a ball, like even he was there at that time, and it's just like no, it's not a ball, okay, just get the ball.
It's not a stationary ball, guy. Yeah, no, I feel that
it doesn't work.
Yeah, but sometimes you need it to work for social acceptance, right?
What do you understand why? I mean, if we're talking about the dynamics, not that you have to go into all that, but like, how would it be a ball of stationary with everything? Because then it would have to be like the attractive force would have to be huge for everything to be revolving around the Earth. Like, is that a nodal point in space that they've got some kind of like theory behind that makes sense in that way, or is it just modeled
I
out.
think
So
they
it
would
makes
just
sense.
take their conception of gravity and apply it to a local flat area projected in a station, in a geocentric coordinate system where space isn't moving or anything, right?
And the force is strong enough. I mean, wouldn't you think it would be a stronger force if that was the case?
Well, if
Because
you don't have
it would be the
to,
center.
if you don't have to actually verify it, right? You could mathematically extrapolate what forces would be required, and then say that you're accounting for these things, physically, and then just not.
Okay, so
Right?
they're having to finagle it almost themselves to make it work.
Well, yeah, like mathematically, it's gonna look solid, right? They're gonna be like, oh yeah, dog, like this is how we put people on the in the direction that they need to go when they're going into orbits, right? But then they don't actually go into orbit, right? But
Well,
mathematically,
that's the whole point, though. Is that the dynamics would show it. You would think if they're showing the dynamics, then that would actually expose the
right?
math, which is what it's supposed to
Well,
do.
no, they have the dynamic math, but they don't have to prove it because the spaceship or the rocket, when it just goes out of scene, it just they say it's going over the curve or whatever, you know, but it just goes out
Okay.
into space. So like they've got the math, they just don't have to back it up. You know what I'm saying? Because that would be the falsification of their fake dynamics, right?
You
Realizing
know
that the
what?
rocket doesn't go anywhere.
It's something that blown my mind even when I was a global. Is like they was able to send some satellite near the sun, but they missed the distance of the sun at some point. Like they changed the distance of sun, but every other computation is right.
Oh yeah. When they were gonna, when they were gonna adjust it, where it would have literally affected everything because it's all based off of that.
Yeah, yeah. That's my point. Yeah. And
Yeah, yeah,
they use satellite with wrong wrong data, and it worked.
yep, yeah. Have you ever heard of the what's it called? The Voyager 1 and Voyager 2. I forget which Voyager's out there, but whichever one's the furthest, right? Apparently, it's so far out there, right, that it passed this thing called the magnetosphere or something, some giant so-called plasma wall, blah blah blah, right? So it's way out there, right? And it sends a signal back with less energy that it takes to turn on a light bulb in your refrigerator by like an insane order of magnitude, like millions of orders,
Yeah.
right? And
They
then what's
Yeah.
that?
Go ahead. Go
Yeah, so they send this data signal back, right? And it takes like I forget, like three hours or some shit, based on the speed of light and a distance of 18 quad billion or something, right? So they get this signal back, right? What the including the inverse square wall law, attenuation of light, anything like as this little fragment of signal propagation is going through this vacuum or whatever, and then it hits this magnetosphere, plasma shield, and all this stuff, and then it hits
They will
us, and then
they would need us to do
dude,
this transmission.
what's that?
They would need ASP. Have you heard about ASP? Uh,
What's that?
HAAFP.
Aft.
HAAFP?
F,
No, AFT. AFT, aft, right?
P comme P like
AF,
Paul.
AFP. Okay.
Yeah.
What is it?
It's a huge platform, radio platform that consume a huge power to do some tests on the magnetosphere of Earth. And they would need use something like that to be able to transmit signal at those distance.
Oh, I'm sorry. It wasn't the magnetosphere of the Earth. It was this other thing that they say that we're encased in. That's
Yeah, it's
from the sun.
you speak about. Oh, I don't recall the name. Yeah, but I
Yeah,
see.
yeah. It's something, right? But anyway, the point being though is that this like little tiny insignificant propagation, they pick this signal up somehow and get
I
this
will
data from like
I
it's
don't
insane.
know about I don't know how to pronounce this in English. I will try to find some link for you. High frequency auroral active auroral research program.
No, never heard of it. Is that where
Yeah.
they have the giant antenna array to get the
Yeah,
signal?
exactly.
Because
Exactly.
yeah. So that's how they say they get the signal, that they made a big catcher's mitt basically,
Yeah,
and it's
yeah, but um, I have done some
oh
radio
hard.
work. I am not an expert in radio, but I used to. I am an embed developed engineer, so I have done some radio software and so on. And like with tiny signal, we can reach without a competitive antenna. We can reach like maybe 100 kilometers. So it's the farthest you can you can get with a good reception system. I mean,
Oh,
if
wow.
it's exponential. The power needed to catch that, it's exponential. The problem
See,
is
yeah, sorry, that's what I thought, because the way that they try and make it sound is like, well, we backloaded the capabilities on our end on Earth where we could
yeah,
make, like, where we could compensate for that.
you
But
have
it's like
too
the signal
much
they're
noise.
sending so weak.
You
Yeah,
cannot.
how could you reduce the noise, right?
Yeah, you cannot differentiate your signal from the noise. It's impossible. You need to have the power, the source power to be huge. You
Yeah, it would
cannot.
have to be proportional
Yeah,
to an exact to exact specificity. Yep,
yeah. You
that's what I
cannot.
thought.
You cannot rely on the reception system from that type of get. You could never say, "Oh, it's my signal." I assure you, it's my signal. It's not an error. It's my signal. You know.
Yeah, yeah, cool.
The noise would be like 10 to the power, I don't know, more powerful than the signal, the noise itself.
The background noise would be larger
Yeah,
than the
the
signal. Yeah, no,
background noise.
absolutely. Dude, by an insane order of magnitude, bro.
Yeah. Yeah,
Yeah,
it's a
it's
nonsense.
crazy. It's crazy.
Total
Because
nonsense.
you know where they screw themselves is they always try to brag about this stuff, and they're like, think of a refrigerator light, and then think of like what it would take a million times less power than that. That's what
Yeah,
we send the signal with, and it's like, oh really?
yeah.
Tell me more about your refrigerator light.
I used like to do a transmission at about maybe 2 kilometers max, maybe three, four on a very good line of sight. I used, if I recall correctly, like 10 milliamps, and I was like with very low power radio. And 10 milliamps is like, yeah, 5 times less than the LED system in a fridge. You know.
Crazy, dude.
So the number is not speaking to everybody. I know I will not explain the proportion, but it's like you have the little battery of a watch, of a toy watch, and you use that to send the signal from to Earth from like 3 hours of late years. 3 hours light ago. Like you used just a little battery from watch from. I will find a pic
Cool.
like that. Yeah.
See what we got here. Oops.
You used less than the power of from those battery.
Nice. Shout out to the Swiss. Those guys make really nice batteries, I heard.
Yeah. So they said you used less than that to do the signal transmission. Is what they said.
Crazy.
And this is a phased array antenna. This is a heavily precise directed antenna. So it can send signal very, very, very precisely. It used every antenna is like the dot of a screen pixel. It works exactly the same.
Okay.
We don't are you new perspective?
I'm sorry, what'd you say?
Ah, you are not speaking. Okay.
Oh, am I muted?
Yeah, I have seen you late speaking, but
Oh, I'm sorry. Maybe I was hot micing. Sorry.
yeah, it's mind blowing. Like how they could do that. Um, it's not even. Yeah, I mean, the person who works on the satellite, you just say okay, don't worry, we have the reception system. You know. And people are like, oh, okay, I don't care, I don't take a look, I trust the fact the reception system will be able to take from noise and so on.
Yeah. That's how they get them, dog. How they get them. They're like, we just built a big catcher's mitt, and everyone's like, cool, I like catcher's mitts. You know?
Yeah. It was great, actually. Over at Geo's just now, I asked Labette if he could just explain a little bit about working at the space agency and how it was that they were compartmentalized enough to keep him believing that the satellites were giving him the data and all that. And he was going into a whole explanation that I think probably triggered a bunch of people because he was like, you could be like right there, and he was like so well hit. Like there was 3 doors you had to get through sometimes to go with certain sections, and you were just like giving data to one person, you have no idea what they're doing with it. And yeah.
I have used the metaphor of the black box. So it's like when you cannot work on the company without singing some confidentiality things, the first things. And when you work, you have just input data, output data, and you connect to a black box. Someone has done, and you only know how to put the data in it and how to output the data, and you don't know how it's done. So it's only a bunch of black box put together, and I was confronted to the fact that I would debug some software without even having the true data, only false data. Because it's so heavily compartmentalized that I could not even test my software on the true data.
Yeah. It's locked tight.
Sorry,
Perfectly designed to keep people believing it without knowing what the next person's doing. So and they very well structured.
But like, don't you know that GPS proves we live on a globe?
Yeah, man. What I was saying is like I can be sure every the companies that have done the so-called GPS satellites, toward one based satellites, they at some point they know, because it's army and so on. At some point, at some level, they know the true shape of Earth, but every company, ST Microelectronics, Texas Instruments, who have done the GPS receiver systems, I am sure every teams that have worked on it believe we are on the globe. I am sure.
Yeah.
They believe we are on the globe because they are giving someone somewhere give some black box and say, okay, here's some matrix, here's some input data, and you have your output data. And what you are doing is only a radio receiver system that gets the data and output something. So Like, no, everyone is not in it, and you don't need to. You just only need to control every part of your team system. It's just you have to do, and you get only the data need to build something for the team occurring. So one team is doing some vectorization software, other team is doing some I don't know some reception system. The other team is doing some black box to some box to put it in a satellite. The other team is doing the emission system with the parameters given. So if you tell, you can you have an energy problem, or you could totally be low power. Don't worry. Well, how they could imagine the satellite will not be in space?
So let me ask you a question, Labat. If you have some working knowledge of GPS, doesn't GPS use a ECEF coordinate system, meaning a Earth-centered, Earth-fixed coordinate system, as its like basis?
You really need to check that, but because clearly it's a XYZ system. It's clearly a XYZ system, so it's a Euclidean geometry system, but it plots you on a globe on the XYZ system. And I don't recall, because it's a long time, I don't recall the Earth moving in the system. So yes, it's an ECU system in my memory. But I don't want to make the claim because I don't have the data sheet and so on the hand. But yeah, if I remember correctly, it's a XYZ system on Earth reference set system. So not moving.
Yeah, well, the ECEF is the XYZ coordinate system, and so it's a Cartesian coordinate system where the axis passes through the equator and prime meridian intersection. The Z passes through the North Pole, and the Y is orthogonal to the X and Z. And so basically, your meeting point is at the center of the Earth.
Yeah, it's exactly that. What I recall is exactly that. Yeah. So I did not see the screen. It's okay. There we go.
Yeah, you're good. Napalm, to answer or to add on to that. So I put 3 PDFs in there. Those are the what do they call them? Whatever the interface something documents for GPS, like how they work and all that, how it takes its measurements. So it uses a range measurement equation, then obviously in the ECI reference frame first, right? So they take a stationary non-rotating reference frame. So the important distinction with this reference frame is that it is stationary with respect to rotating stars, and then they take that distance that they derive in that first frame and they transform it to the ECEI the ECIE frame. That's not even that. The ECEF frame, the Earth-centered Earth fixed frame, which is a rotating frame with respect to fixed stars. So that's the distinction that they make there for that. If that helps, they start with a fixed position.
Gotcha. And then the ECEF rotating frame.
Yeah, the ECEF is what they say is the one that we live on. They say that's the GW8 ellipsoid or whatever, right? Or the G86, whatever they call it. That's what they say we live
WGS84.
Yeah. And then they say that the Earth-centered frame is like the hypothetical frame that's not real, but it's the inverse, right? So
they transform it from the Earth-centered to the Earth. So they transform from the Earth-centered Earth fixed.
So they take their when you get your GPS signal, that first measurement that it's taking it in the ECI reference frame, meaning stationary fixed reference frame. So it's interpreting everything as stationary and not moving with respect to the with respect to rotating stars. So as if like the background's rotating, but not us.
Gotcha.
Yeah, I can back up. It's what I remember. And as we spoke about the first time we meet, so. But I clearly remember that. But I don't. I have worked only with GPS receiver, and I worked only on my data, and it confirms the like I listen to too much globals. Oh, there is engineer working with GPS. Yeah, I am on. So yeah,
So the
like
first,
I just get my latitude, longitude, and do my stuff. That's a matter of the fact. I did not work in the module GPS receiver. I worked with the GPS receiver and connect to it, asking from satellite, asking from. Oh yeah, I get 4 satellite. I have a strong signal. It's just a black box. It's just a little black box, and I connect to it. And it works every time like that. I don't know if it was clear, but
Yeah, we got you. Yep, the black box concept's great. Yep,
yeah,
like
it's
Schrodinger's cat.
there is not too much people that have worked into the GPS. Like okay, some people have having some module, receiver module, and getting some data. Yeah, there is a lot of people, but I am one too.
I'm sorting my. That's why I'm posting these things in chat. By the way, I've posted the actual burner comps that I'm reading from, and then I'm sorting out some clips that I wanted to read just a little bit of each from whenever that time comes around. Cool. Yeah, I'm working on it right now.
I need to go, guys. It was a pleasure. Thanks for
Awesome work today, man. You did great. That was really
it was
funny,
fun.
really great. Really,
Yeah.
I'll definitely record that and post it for everyone else to hear too.
Yeah, it was funny because
Be right back.
I know that there was 3 Globers and 2 left. Like like they just left. They did not even speak.
Oh, they didn't. Yeah, they were all in the conversation until you came around, and then they just
Yeah,
disappeared.
because I was listening from YouTube, and then I listened to some Globers saying there is no man in space agency that is flat earther, so I just connect quickly.
Right, this is awesome. Yeah, he came in. He's like, "Well, I used to work for a space agency, and I think satellites aren't in space. What do you say to that, people?" And like everyone just like scrambled out of the call. Like what do you say to that if you're a baller? You got somebody here that used to work for a space agency talking about the compartmentalization, talking about how it could totally be spoofed easily, and has maps with GPS data points showing the planes possibly could be going very much slower, it seems. And oh man, that's why I call him the Beast, and he goes by Lebet, by the way, if anyone didn't know that.
Yes,
It's
thanks.
not even fair.
Thanks. So I roll a last cigarette and I go. I need to walk my dog and go to sleep.
Oh yeah. Well, if you want, I could read these excerpts here. I got one more to post, and then I'll just read them in order. I kind of figured out what might be the best way of the best organization for this. Hold on, real quick.
Anyway, Alan, it's great findings as experiment with Sagnac. And that one with the man that has done. Did you hear me? I think he is mute. He is mute.
Oh yeah, Al. I'm gonna wait for Alan to come back before I read any of this too. But I wanted to see what he thought of your. I wanted to see what he thought of your laser setup there. If you wanted to talk to him at all about that or any idea.
It's just a proof of concept for now, but I wanted to ask him about an experiment from Sagnac effect, if it's the same guy that has done it or not. But it's not a problem. Just a curiosity thing. So.
Are you there, Alan?
Yep, I'm back.
Yeah.
Just had to close out the stream real quick.
Yeah. Okay.
Okay, you're not going to include my Michael Brenner stuff?
Oh fuck! No, I'm sorry, man. I was kind of trailing off at the end, and I was having a conversation, in DM on Discord with my buddy, setting up something for Saturday. I totally forgot, man. I apologize, but
That's all right.
fuck. No, my bad.
Well,
but I do
it'll
still
be
want you
part
to
of
read it
this.
because I like
It'll
hearing
be-
you saying it.
Well,
So.
maybe I'll. Well, if Toby's doing a section of it, maybe he hasn't stopped yet. I don't know.
Yeah, he's still live. Yeah, absolutely.
Oh, okay, cool.
Yeah. Let's close out on that real quick so we can wrap
Well,
up.
let Model Builder ask his question. He
Yeah,
has to go.
Oh, sorry, I didn't hear.
You showed me back in the day an experiment about Sagnac effect with someone doing experiment with fiber optic moving through two rods.
Yeah, Ruyang
It
Wang.
was the same guys?
No, this is in 2004. Ruyang Wang, the generalized Sagnac effect.
Yeah, it was. Yeah, it was to prove that Sagnac effect is not gyroscopic. I guess.
Yes. Yeah. So here's the configuration that they had: a little conveyor belt. So the whole thing is made up of a fiber optic that's just wound on it, and then you'll note there the.
Yeah. Okay, I see the pic. Okay, I see the pic. Sorry.
Yeah, and then so on top, and then so there's that red cable there is just tethered to the wheel that's turning the other fiber optic cable, and then that has a tray on it, or like a little plate or whatever, and then there's a fiber optic gyro on that, and that so when the wheel rotates, it picks up that it pulls that fiber optic on that pulley as well, and that also registers the full linear motion of that, and then the fiber optic cable itself that makes up the conveyor, the linear bits, contribute to the full fringe.
Yeah.
Yep.
It's so ingenious. The experiment.
Did you hear me saying that he was saying that if he just presses his finger down on the table that he's got it on, it changes the whole thing, like just a little bit of pressure?
Yeah, but as I say, the new perspective, it's accepted. Like it depends on the wavelength of the lights, so it will detect a quarter of the distance of the wavelength of the light. I don't know if I am clear, and I want Alan to correct me on that because I am not an expert at all. But from what I understand, is like you take my laser. It's like 600. And I will take it easy. It's like 600 micrometers. It's like that, yeah. Nanometers. It's 600 nanometers. So it will catch a quarter of 600 nanometers of movement.
Nice. Did you hear that, Alan?
No, I'm sorry, man. I got distracted.
Oh, okay. He was just saying it's.
No, I am answering to you. So, I wanted Alan to correct me, but anyway, I will take a look to all the functions. So I will get my point at some date. So it's not a
My
problem.
bad.
No, don't worry. I was just saying that it will measure a quarter of the wavelength in distance. Is that correct?
A quarter of the wavelength and distance it'll measure, he said. Is that correct?
Quarter in wavelength and distance.
Yeah. If I have a laser that do 600 nanometers, it will detect a frame shift will loop back every quarter of the wavelength. Is that correct?
Oh, I have
if
no
I
idea.
move my mirror. If I move my mirror,
When you adjust the mirror, yeah. Okay, no. When you adjust the mirror, how it affects the displacement of the fringes?
yeah.
Yeah, there is a component to that. I don't know the exact ratio, but there's even what they mentioned. They did mention something in the Sagnac experiment that I was reading, the deformed pruner guys. So when they had the rotating setup, they actually had to change the orientation of the mirror slightly, because the device is rotating or whatever. It wouldn't be
Okay.
in its original configuration to accept uh, the thing. So they did have to make a slight adjustment. So what they did, that adjustment affects the wavelengths, how you're talking about the distances. So
Yeah.
they adjusted it, took measurements, and then adjusted it back, took measurements, compared it,
I'm
averaged it
speaking
out to
about.
cancel it.
Uh,
So yeah, you can absolutely, that absolutely is a contributing factor. The amount that it displaces, I just don't know the ratio off the top of my head.
Yeah, okay. So it's not linear, but you get the point, perspective.
Mhm.
I am not right about the quarter of wavelengths because it implies a lot of other factors, but the point is the setup is able to detect a quarter of, it's an approximation, able to detect a quarter of the wavelengths when I move the mirror. So like that, I can detect this very slight movement. And it's the point of every experiment using the Sagnac effect.
Did you get that, Alan? Are you
It's
still?
for you. It's for
Sorry,
you.
sorry, dude. I entered a full conversation with someone in PM on Discord, man. I'm sorry.
I am speaking to you, new perspective. So
Oh, okay.
it's okay.
Now, yeah, and I'm trying to organize the thing I'm about to read to end the
Yeah,
cosmology show.
in fact, it will move. It will move the fringe. So when you have your setup, it will. If you have a perfect setup, stable and no noise, the fringe will not move. It will display some fringe, and it will not move. But as soon as you put some forces in the mirror, even slightest one, you will displace the mirror. Even a slight displacement will create what we call a fringe shift. So the fringe that is displayed will move. Okay, and this move is in perfect correlation with the displacement of the mirror.
Ah, okay. Yeah.
So you
And so
can use it to measure things. Okay.
gotcha. And their conflation, we were talking before you came in, I think right before you came in, the convenient conflation with the movement of what could be called the ether wind, or the direction of the propagation of light being faster in one direction, and then they conveniently conflated that with the rotation of Earth, and
Exactly.
you almost have to think that they might have reverse engineered. Well, obviously they reverse engineered it, but how close how is it actually mistakable as the movement of Earth, or is it pretty far off from what the direction
No,
of light? Yeah, it's different, right?
it is. It is. And the matter of the fact is that Michelson-Morley did not detect the movement of the Earth through the sun.
Right, right. They
So,
didn't. Yeah, but they were
so
conflating. Well, even guys like Wang that Alan's been studying those guys have somehow been able to, like, even
but
like Dayton Miller, like Alan said, was able to somehow configure it mathematically to still believe that the Earth was rotating around the
yeah,
sun. You know.
yeah. Just to answer your question, I lost my time. You have a specific
Oh, I was
question.
saying, was it close? Was it close to the orbit of? I mean,
Yeah, yeah. Thank
spin
you,
of the
thank you.
Earth. Was it close
Yeah,
enough to
as far
escape?
as I know, it's really close. It's really close, but it seems to have some change with altitude and latitude. I don't know I cannot tell, but for me it's really close because This is the same mathematical model but reversed. So
Gotcha. All right. Well, you know what? Maybe I should try to, since we're going to wrap up the show here, I should try to read all these little things that I picked out. And let me say that the reason I am choosing these, Alan, are you still there? You can at least listen to this part, even if you don't have it on your show.
Negative, Ghost Rider. I'm in the middle of a full debate in PM, and I'm not trying to lose this. So
Okay. All right. Cool. Well, you can hear it back. So but the reason, Alan, the reason I was actually asking if you were going to listen to this is I was going to say that because it has to do with what we were talking about as far as like the heliocentrism versus geocentrism, and the dynamics and the kinematics, and that it kind of all relates. I've devised a way to present how I could make some of the quotes from Michael Brenner or some of his excerpts kind of wrap up the discussion. So it might be perfect for the end of the show that you could even add to yours if you ended up liking it or whatever. Doesn't matter. But so I'm going to start with this. He talks about Copernicus. It's a quote from Copernicus saying, "Now, when from time to time there are offered for one and the same notion different hypotheses, the astronomer will accept above all others the one which is the easiest to grasp. The philosopher will perhaps rather seek the semblance of truth. Here," and then he says, "here we see that Copernicus is here we see that for Copernicus, it still was the natural philosopher who wanted knowledge, whereas the astronomer was just seen as a number cruncher and who wanted it to be as easy as possible, irrespective of any relation to the reality. Copernicus was perfectly aware of that when he warned us to take this computation, take his computations at face value." And then he quotes Copernicus again. He says, "So far as hypotheses are concerned, let no one expect anything certain from astronomy, which cannot furnish it, lest he accept as the truth ideas conceived for another purpose, and depart from this study a greater fool than when he entered it. Farewell." It says, "Astoundingly, when you look closely, Copernicus did not succeed in making it simpler or easier to grasp, as he claimed." And then he says, Otto Nugabar, is that a French name there, by the way? Otto Nugabar? Otto Nugabar.
I don't see where it is. Can you read?
That's okay. It doesn't matter. It probably is French, but Otto. Anyway, so he says the eminent history of Otto Nugaber, the eminent historian of science, says the popular belief in Copernicus's heliocentrism system continues a significant simplification of the Ptolemaic system is obviously wrong. The choice of the reference system has no effect on the structure of the model, and the Copernican models themselves require about twice as many circles as the Ptolemaic models and are far less elegant and adaptable. Modern historians, making ample use of the advantage of hindsight, stress the revolutionary significance of the heliocentric system and the simplification it has introduced. In fact, the actual computation of the planetary positions follow exactly the ancient patterns, and the results are the same. The Copernican solar theory is definitely a step in the wrong direction for the actual computation, as well as the underlying kinematic concept. And then the next part of it, he says, physical reality resides in physical bodies and not in the observer opinions. And that is the crux with all relativity. It gives zero information about an autonomous physical reality. It can be made to be anything you like. It becomes the arbitrary product of the biased mind. And then he has one quote, as Louis Hassan put it, if the theory of relativity is regarded simply as a new system of units, it can be made consistent, but it serves no useful purpose. And so that kind of leads us in. He mentions the kinematics there. And then the next part,
I really need to go. I am sorry.
Okay, yeah, you can hear back the rest of it. I'm just going to keep with what the excerpts are that I figured out. Thanks so much for all your work today.
Yeah, it's a pleasure.
All right. Talk to you soon, bro. All right.
Bye.
So then, take care. So then, the reason that I wanted to lead from the heliocentrism versus geocentrism stuff that he was pointing out, how the models are, equivalent, kinematically, mathematically at least, and then as far as the dynamics goes, what I'm about to get into, and he summarizes it in a couple of different comments that I've made, and in this one, it's in response to the question, why is centripetal force not a real force? And it's kind of a misformed question, or maybe not the appropriate question, because what they tell us with the heliocentrism is that the geocentric force, I mean the centripetal versus centrifugal, the centrifugal force is a fictitious force, and that's where really it all falls apart. It really dynamically falls apart with the centrifugal force. You can't just call it a pseudo force, and then because they are saying that it cancels out with a centripetal force, so we don't have to worry about it. But the basic facts are, you wouldn't get one orbit around the sun. You would continue going because there is a centrifugal force. And then this paper does a good job, or this part that I'm about to read does a good job of explaining why. And it goes into the dynamic kinematic stuff. So he says, so the question is, why is centripetal force not a real force? And he answers, that's a question that's at least pointing in the right direction for once. Usually it's the centrifugal force that is associated with not being real. But the question about forces is not about being real or not real. Forces must be real, or they can't be called forces. The introduction of pseudo-force or fictitious force is the same as introducing angles, entities, that effectuate something without being corporeal. But Newton mechanics is based on corporeal, that is, masses having entities. Without mass, no force. Now, if we look at how mathematicians treat the problem, we see that they fully remain in their domain of mathematics, which is geometry and kinematics, and never ever venture out into the world of dynamics. They go so far as to postulate these differences do not exist and are made up by me. I kid you not. Professor Torsten Heel here on Quora does this every time it is mentioned. Just to remind everybody that it is not the case here. It is not the case. Here are the respective definitions picked straight from the Oxford Dictionary. Geometry, the branch of mathematics concerned with properties and relations of points, lines, surfaces, and solids. Kinematics, the branch of mechanics concerned with the motions of objects without reference to the force which caused the motion. And then there's dynamics, which is the branch of mechanics concerned with the motion of bodies under the action of forces. And then he goes into the other part I wanted to read was that he explains it, that something that has no degree of freedom cannot push you. When you lean against a house, does the house push you, or do you push the house? The situation is not symmetrical because it is the house. If the house disappeared, you would fall flat on your nose. Would you disappear? Would you disappear? The house wouldn't notice. A popular example for the obfuscation around the notion of centripetal force is the Gravity Fair ground ride, with the picture of the one when you cling to the walls when they spin it. Here it is claimed that the spinning structure is applying a centripetal force onto you, and that's all there is to it. But the structure is rigid in the centripetal direction and can thus not push you. It is you who tries to push the rigid structure out of your way, and if the structure is not strong enough, you break through in a direction away from the center. Not the structure collapses toward the center, which would be the case would a centripetal force be acting. And then so basically that was the part I wanted to read about the centripetal versus the centrifugal force, because if it makes sense just from hearing me read it to anybody, but basically you can't just ignore the centrifugal force, but they have to make it a centripetal force, otherwise they wouldn't have their orbits. So they basically just had, okay, so here's the other part here. It says, he's going into another example, and he says, if the hammer thrower wants to persuade the ball to go in a circle around him, he has to overcome the innate power of resistance of the ball to do so. Again, the leash is a rigid structure which cannot pull the ball. It is the ball which has the necessary degree of freedom to stretch the leash. And if the leash would be somewhat flexible, the length of the leash would increase. It would stretch, which is a clear sign that what is active here is the centrifugal force applied to the ball, not a contracting centripetal force by the leash. The inertia of the ball is the force. That is the fundamental Newton definition of force, and mainstream just wants to obfuscate this because the Newtonian cosmology would collapse under the weight of centrifugal reality. And that's really the crux of the biscuit, that if anyone's missed that yet, what they've done is they've made it so that the centrifugal force is considered pseudo force, so they can just not even think about it. And people that understand mathematics can apply the kinematics and the geometry and not even think twice about it, because they've defined centrifugal as a pseudo force or fictitious force, when really it is the force that's causing anything to go in a circle, like the example with the water in a bucket. When you're swinging that bucket, it's the water pushing against the bucket that's the force. But they have to make it to coincide with what they pretend gravity's doing, as a pulling force, that gravity's pulling everything in, and that's where the force is. And it's the opposite, and there you go, heliocentrism done right there. If that is the case, then that is not even possible for us to continue believing in it, because he's pointing out very clearly that's the case. And when you think about it logically, it's you pushing against the car when you go around a turn. You're the force on the door, and they want to make it a pseudo force because it's in a curve and all these other kind of conflations that they want to make people believe, and people totally believe it and totally accept it because they're just like plugging in the information and going with what they're told to calculate. And then I'll end this with saying that there's one part that I highlighted in one of these comps that I think is pretty good. He says, so what does all this tell us? That your intellect is your only protection against mathematical trickery, and you have to hone in your rationale and tend to your logical glands, lest they wither under the lack of rain in the modern parched environment. So yeah, it's a great way to end it off, maybe. And it kind of wraps up the heliocentric versus geocentric, and the how they were able to conflate it. And the geocentric stuff, I don't know. It'd be interesting to find out when that talk comes up with Alan's boy, if the centrifugal plays a part, or if he's just accepting that same kind of idea, because I guess he would have to, because everything's pulling towards the center, and that would be completely dynamically wrong too. So that'd be interesting to figure out too.
Cool. I'm gonna.
All right.